Welcome to Squirrel Trails. I'm David.
And I'm Al.
And let's talk about AI.
So, AI is a bit of a passion of mine. It's something I'm very I have a lot of things I'm interested in. Let's just sign up for that fact.
Passion.
So
where does that stop?
Yeah, let's just keep going.
Yep.
It'd be nice if I was passionate about something other than electronics.
Yep, that's a whole separate video.
It's a whole separate video.
Al passions. 2 hours later.
Okay, and let's start over again at 40 seconds. So
Okay.
The reality here is, I studied artificial intelligence in the late 80s. For those of you that know me or don't know me, well, that would be all of you now that I think about it. I've been following technology since 1981. Actually, probably, take that back, late 70s.
Okay.
Back in college.
When they're first developing it.
Yes, and we didn't do it actually with granite wheels at that point in time, although some of the people I work with think I did. In the late 80s, I started really looking at artificial intelligence. It was a very hot topic. A product called Brain Maker had come out.
Okay.
And no, it did not make brains, but what it did was introduce a very inexpensive tool, like $50 back then, for you to start doing your own neural networking programming.
Okay.
So you could design some things and test out the concepts.
What would it design back then?
Well, two things it was really used for, and this is kind of the scary part, sports betting. Because you could feed it a whole mass of data.
Yeah.
And the story from the guy that put it together was this way. He had been...
A bookie?
No, but he knew some.
Okay, sure.
So it's a close group. So they had been provided a mass of data and had said, train this and see how well you can predict the results.
Okay.
And so they crunched through the data, and they didn't tell us what the results were, what this is. When they told the story, they're just crunching the data.
Sure.
And they true it up a little bit as they're going, and they crunch some more data, and they come back and they say, yeah, we're getting at about, 60, 70% accuracy, maybe a little higher.
Nice.
And the guys go, they're doing this with, score, we want it, thank you. And they're like, why? Because that's not accurate enough to do much of anything in a business situation.
True.
And they're
Yeah.
going, no, the best guys in the world get this at about 60%, maybe.
Wow.
So it's forgotten the exact numbers. This was 1989, and I'm not as young as I used to be, but yeah, no, that was the actual story. It's a great story. Kicked off a number of other industries within this. Lots of magazines out doing artificial intelligence. And I can probably rattle for way longer than David will let me on some of this stuff.
So 20 years later.
20 years later. We're still using artificial intelligence, but we call a lot of it now machine learning. There's some differences that are in there, but the basic concepts are still there.
In a brief note, what's the difference between kind of artificial intelligence? I mean, we were just talking off camera about kind of different ways of learning.
There's a number of different techniques that you can use in this thing, and now you're going to make me show that I'm an idiot. But thank you.
Every day.
Every day. So a number of techniques are used to do that training. Some have what I'm used to using is what's called back propagation,
Okay.
where you have a mess of data that you look at. You've identified some kind of key indicators that are there, and based on that data and tests that you've run, so you know that given certain situations, you should see a given result.
Okay.
So if you crunch through enough of that data, enough variations of that data, you should start seeing some generalized situations.
Okay. Well, what about, so I've seen some people put together I think it's generational
learning process where you do some design work, you let it do some training, you see which one's doing the best, and you trim out the kind of stuff that's not really working.
Yep.
And then you let it do some more training.
Okay.
And that concept of continual learning is the same kind of a basis. The system just continues to take the data that's been provided to it, check it against results, and seeing where am I getting the best results. And the fun part of this is it's actually beginning to learn to generalize a bit.
Sure.
As opposed to like an expert system, where an expert system says, based upon this set of questions, I'm going to tell you that the answer is Y.
Okay.
That's the classic one is, can you tell me what type of an animal this is?
Okay.
And you answer
So
a
is
bunch
that
of
kind of
questions.
what your Alexa or Siri kind of when you ask a question, is is it using that kind of a basic?
So what's actually happening with those things, we're going to get emails that tell me I don't know what I'm talking about, but what else is new?
Yeah,
I get
right.
that at my job.
Yeah, right.
So
And if we're wrong, let us know below.
Yeah.
And then don't forget to subscribe and tell us more.
and we'll learn. This
Yeah.
is how we learn. Those techniques are what's used called voice recognition, and voice recognition is very much about that machine learning process.
But the question, so we ask it a question, is it getting it from multiple sources? Is it getting it from one source? So when I ask Alexa, what's the capital of Minnesota?
So what's happening with Alexa when it does that, it has to interpret the words that you've said,
Okay, yep.
frame that up into a query of some kind,
Okay.
and then it executes that query against its database.
Sure. So is that the expert learning?
That's kind of the expert learning as it's going through. There's a couple of things that are going on with that. One is the whole process of learning speech recognition.
Okay.
So that's how do I take the way you and I talk, and oh, by the way, we talk differently.
Sure, we do.
And
I stutter a lot more than you do.
Not only that, you compare somebody, and we'll just use the United States as an example. You take somebody from Brooklyn, New York, and somebody from deep South Louisiana.
True.
They're very, very different. Now, there's some similarities. Again, I could do this for hours.
Yep.
It might even be right occasionally.
Yeah.
But
They should actually have a Alexa that's from like the deep South talk that way down there.
Oh.
So just
I need a Cookie Monster Alexa.
yeah, right. They have one. You can actually tell your Alexa device to speak Pokemon like Pikachu.
Oh, good.
Yeah, right. Yeah.
Okay, so let's say you were getting it to speak Klingon. Same kind of a concept.
Okay.
You'd
Yep,
have to
yep.
take it, so voice recognition, transfer it to a language, then build out of that natural language technique. How do I build that query based on the words
Sure.
that are there? And if we want more than that, I'm going to have to break down and actually do a little more programming and study this some more.
Yeah,
which
sure.
would be cool.
So let's
I'm
kinda
not
get-
do anything for the next 2 weeks, just FYI.
So don't let your boss see this.
No, he'd tell me to go on vacation and have fun. Let's be honest. It's closing on at the end of the year. I still have 2 weeks of vacation to take, and it's in my annual review. I have to take all my vacation this year.
Lucky you.
How many people actually have to have that in their review?
Yeah, you're the only one. So, kind of back to our original question.
Yeah, for those three of you that are still on.
Right? Yep. So, learning. So, what it's getting all the information from a database.
Right. So as you learn, you provide it data, in some cases fairly structured data, in some cases unstructured data, to provide that information to it so it can learn. The challenge that comes into play is its learning is going to be based on its data.
Sure.
So if you take somebody, and I'll try not to get real political here, but if you take somebody that's going to a given school, and they're going to come out of school knowing what was in those textbooks.
Okay. Yep.
And that's what they're going to learn from.
Yep.
So
They'll know that information.
They'll know that information. And that's why it's important to get a broad education, so you're not just don't know that stuff, and
Yeah.
you can challenge it. And education is about learning and challenging. So we can't all agree, and nor should we always agree when we're learning. That's a good process of learning is a give and take. So the same thing is basically true with artificial intelligence.
Okay.
You're going to have some differences for it to be able to generalize.
Does it like differences?
Not generally.
So what is it? What happens? We're talking about kind of a human brain kind of can manage that difference and understand the difference. But
Can it?
So if you know something, if you hear enough people saying that the opposite, are you going to change your mind?
Yeah, we actually quite often enter into a feeling of cognitive dissonance. If we hear the opposite of what we believe often enough, it begins to challenge some of our underlying beliefs, and we end up kind of not necessarily understanding where we're going to go.
Yeah.
So the same thing can happen with a tool that is learning. Is if the data is too broad,
Okay.
and it gets, and there's not enough consistency in the responses, then it's not going to be able to come to a cohesive answer.
So what would happen?
And so it actually would have failure rates of like the sports betting. You end up having numbers that are very relatively low.
Okay.
So what's happened recently as we've seen more and more neural AI tools coming out is that individuals, in particular governments and large institutions, are loving it because I can buy a tool and I don't have to be accused of any bias. I can say, I'm running this tool. It's telling me who is the first person I need to see at the hospital, who should get these benefits first, who are the most needy individuals, because a computer's telling me this. I don't have to think about it anymore.
Yep, exactly.
The challenge being, and it's not well understood, and this is where you're seeing a number of articles coming out. We'll list some of them.
Yep, we'll find the articles down below.
And it's where it's getting into is, well, that's true, subject to the data that you've had presented and the biases within the data. Now, the data wasn't intended to be biased.
Well, or was it?
Yeah, I'm not going down that path yet. But it is one of those. It is one of those things that comes into play that when you're using a new technology, you have to learn both the ups and downs of that technology. Artificial intelligence is not a new technology because we've been doing it for 20,
well, our
30
life,
years.
Our brain is artificial intelligence.
And don't go down there. But as a yours, yes. The rest of us, maybe not. So I'm not sure if the word artificial or intelligence is wrong with you. We'll talk about it later.
Okay.
So,
that conversation we'll have off camera.
yeah. Yes. And if you see bandages on me next week, it's because but the channel, we've been doing this for call it 30 years. And one of the interesting things that came out was an article where a hospital were using a artificial intelligence tool to determine which person should be seen first based upon their needs.
Okay, yep.
It's a kind of triage, natural thing. Nurses have done it for centuries.
Yeah.
I'm doing something similar when it comes to issues, but who needs to be seen first is kind of a critical thing.
Definitely, yeah.
And so,
especially in a life and death situation.
Yeah, absolutely. So they decided to train the data to do this, and in some cases they were like, okay, this will work. But what they found was, in this situation, certain classifications, and in this case it was actually people of color that were not being seen as frequently. Now, it wasn't because the people running the system were racist. They were trying to take racism out of the equation.
Okay.
Take the human out, the system will tell us how it's done. However, when the training data was used, one of the things that they used to factor in who should be seen first was how much money had been that person had been spending on healthcare, because kind of makes sense. The more money you've had to spend on healthcare, probably the more challenges you have.
Sure.
That would be true of certainly people that I know. If you're not feeling very well, you've been to the hospital more frequently.
Yeah.
But the challenge is certain social classes don't always get to the hospital or get to be seen as frequently.
Or want to go to the hospital.
Or want to go to the hospital because... So that gets backed out of the data.
Yep. I mean, I'd never be seen. I do not go.
Yeah, you do not go to the doctor.
I will not go.
Yeah.
I will.
Now, fortunately, the way the tool works is it looks at the symptoms that they were coming in with, and running it back the kind of looking at those things that people were presenting with based upon that. So it's not like this is David. Okay, David's always going to be a problem because he never comes in. We don't know what to do with him.
Yeah.
True story, but that's not how the system would work.
Yep.
What it would say is people that have the same background, same types of situations that you or I have had, they would determine who is next to be seen based upon that, and all of it based on medical data. not racial demographics,
just-
nothing like that, just
Yep,
medical data. But because the data that was used had inherent biases in it, not biases of intent,
Just
but because of where they pulled the data from.
so will data always have a bias?
Yeah, data's probably almost
So
always going to have a bias.
Is that something that, as a culture, we should understand?
Yes, I think
'cause
that's key. Yes.
Because I mean, there's always someone's always gonna be left out. Someone's always gonna be bottom or top, and that's just.
Yeah.
So do we need to understand that we can't make everything even. There's almost never a way to, there may be never a way to make things on an equal plane, especially when it comes to understanding data.
Right. Okay. Because data. Okay. We get into the conversation of data versus information, which is always a fun one to have. I mean, data without an understanding of how you're going to use it and what you're going to do, it's not information. It's just simply datum.
Yep.
So, and yes, for those of you that are younger, you know that I'm using the older term of data because I'm old. So just FYI.
Data.
So I'll put it this way. If you're making financial decisions, if you're making health decisions, understanding the nuances of the data that you've got is really important. There's a concept in data security right now where we're trying to move from more qualitative forms of risk. Is it high? Is it medium? Is it low?
Yep.
Or to more quantitative. How can I measure the amount of risk? And one of the challenges with doing that with these tools is you're going to base that analysis based upon the information that you have. The broader amount of data that you have to be able to draw that information from without introducing your biases or without introducing the biases of, well, I didn't get hacked because, well, yeah, but I'm on a system that nobody ever attacks.
So are we going to always blame the data or the algorithm?
Probably will. We're humans. We'll always blame something else.
I mean, so is it because part of it is because we don't understand it? And
Yeah.
But I mean, it's
Well, to your point, yes, because I can blame the data. If I'm the customer service rep on the phone, I give an answer because that's what the algorithm told me to say.
Yeah.
And if the car blows up on you because, oh, no, not that switch, kind of a thing.
Sure.
I'm going to say, but the algorithm told me that's what it was. So it's very easy to come away with that.
okay.
And because it's an algorithm, we think we don't necessarily have to train the users to use it because the system's just going to present that information.
Okay. Yeah.
So at the end of the day, if you're using artificial intelligence, think about how the system was developed. What are and if you're doing this for work and you're building these tools, think about your data. Where did data come from? Challenge yourself, challenge that data to say, is it giving you the results that you're expecting? And simply because it's giving you results that you don't like doesn't mean that it's wrong.
So it's always about, I mean, should we ask the question first or ask the question after?
Both.
Okay.
So the thing with artificial intelligence,
Don't trust it.
I'm not going to say that, but I'm going to say, think about how it was trained, think about how it was learned, and challenge yourself as a developer to make sure you're challenging the biases within the data as it relates to the data that you've got. And look at the results, and then challenge the results.
But yeah. Okay. Yeah.
It's like most things in
Yeah.
life. If you're not thinking about it, you should be. Challenge what you see, challenge what you hear. I don't care if it's a tool or if it's the radio.
Perfect. With that, don't forget to like and subscribe. And don't forget there's some articles down below that be good references for you to check out. So with that,
Stay squirrely.
and don't forget to check out our new clothing line.
We will have our shirts on next week as we've started doing this.
We finally have some shirts with logos and that kind of stuff. So the merch. There will be a link down to the merch down below.
Thank you, folks. Appreciate your time, and let us know when we're crazy.
Every day.